Okay, my friends, this is Roger once again. After 60 years, we finally discover what John Glenn saw. Listen to this. This is Spacelink TV. Here goes.
They line up like they're luminescent. I never saw anything like it. They're around the little, they're coming by the capsule, and they look like little stars, a whole shower of them coming by. They swirl around the capsule and go in front of the window, and they're all brilliantly lighted. They probably average maybe 7 or 8 feet apart, but I can see them all down below me also. Negative. They're very slow. They're not going away from me more than maybe 3 or 4 miles per hour. They're going at the same speed I am, approximately. They're only very slightly under my speed. Over. They do have a different motion though from me, because they swirl around the capsule and then depart back the way that I am looking.
See, they can't hear him now because...
Are you receiving? Over.
He's in the middle of these and they're emitting static.
There are literally thousands of them. This is Friendship 7. Am I in contact with anyone? Over.
No, he's not, because he's in the middle of a zone of particles.
This has been going on since about 1 plus 1:05. Over. Just after I remarked about the sunset, I looked back up and looked out the window.
Sunset.
And all the little swirl of particles was going by. Over.
It's sunrise and sunset. See, he's still in the middle of the static.
That's Friendship 7 broadcasting in the blind. Sunrise has come up behind in the periscope. It was brilliant in the scope, a brilliant red as it approached the horizon and came up. And just as I looked back up out the window, I had literally thousands of small luminous particles swirling around the capsule and going away from me at maybe 3 to 5 miles per hour. Now that I am out in the bright sun, they seem to have disappeared. It was just as the sun was coming up.
That's the key to the whole thing. He's in the shadow of the Earth, and the light is illuminating all the particles of dust and sand and so forth that are out there. And believe me, there is a ton of it. All right, this is the National Science Foundation. They realize now that Earth's atmosphere is far dustier than previously believed. Out where Glenn was, he's seeing all these particles, just like you're walking in a barn and the light is coming through the little cracks in the thing, and you can see all the little particles floating around in the light. It's the exact same thing. This is dust and sand. They've found from sandstorms enormous amounts of this debris in the outer atmosphere where Glenn was. That's why it was all staticky, and they're all being hit by light and creating static. So he's trying to broadcast through that, and he's in the middle of just... They're broadcasting too. The same thing he's doing. Okay, this is something that they just haven't been considering, is all the dust, and the atmosphere is saturated with dust out there. They had no clue that it was out there. And they originally thought, well, look here, look at this. Particles in the upper atmosphere slow down global warming. No, they don't. They accelerate it. And these are, now they say, Earth's atmosphere far dustier than previously believed. And it comes down here, it says, coarse dust particles warm Earth's climate by absorbing both incoming radiation from the sun and outgoing radiation from Earth. Not only that, it scrubs as we scrub through the particles that are colliding with it. That's what's creating all that static that Glenn is hearing. Okay, here's the situation. We are spinning through space, rotating around the sun, being dragged on an arm of the Milky Way. A lot of interaction with our atmosphere and whatever is out here, which was considered to be nothing. Well, we know now that is not true. This is saturated with light particles, which I have shown you or will. They are particles. They scrub here. They create ions, and they create static as they bang into the particles of dust that are out there. Now, what's going on with Glenn? He's coming around this way, and just as he's getting here, he's seeing all of these particles wrapping around him. Well, light comes down here. Here's what happens. The light comes out of the sun. It comes down, it comes down, it comes down. And as it hits our atmosphere, it's actually being sucked down to the earth. So it starts to sort of wrap around the earth. So he's seeing the sunlight still in the shadow of the earth and illuminating the particles that he's looking into. That's exactly what you're seeing there. All right, does that make sense to you? Think about this carefully. Normally the particles spin, and I'm showing there's slow spinning ones and there's fast spinning ones, and that makes the different colors that Glenn talks about. Well, he's out here. He's right there, or he's right over here. And the light comes down, and because of the attraction of the earth to every particle there is, the earth will absorb it. If it'll get close enough, it'll suck it right down. It starts to pull it in, and it'll actually wrap around the earth and trail off behind the earth. So it doesn't go just straight back this way. Light coming close enough to the earth will travel around the earth and actually wrap around like that and just continue on going. That's what he's seeing, is these illuminated particles. Just like you would see something, if you were in the dark and there was particles in the light, like in a dusty old barn, that's what you would see, and that's what he's seeing. And the reason that they are these certain distances apart is they push each other. They want to find their own region. They don't want to be snugged up to another one. They push. That's what particles do. They push apart. It's called the Casimir effect. All right, let's just sum it up. John Glenn is coming around the earth, and he's seeing all these particles, and they're swirling around him as he goes through them. But the earth is also spinning. The atmosphere goes with the earth, so he's traveling along with the earth as well. And he's hitting in with these particles, and they're swirling around him. All right, so here's what he's saying. This is Friendship 7. I'll try to describe what I'm in here. I'm in a big mass of very small particles. These are dust. Brilliantly lit up like they're luminescent. They're glowing, and they are glowing because they're being hit by sunlight, and they're radiating just like they do in a barn in a sunlight beam. He says, I never saw anything like it. They round a little. I don't know what exactly that means, whether they're round or they round him. They're coming by the capsule. All right, so he's going through them, and they're coming by the capsule. They look like little stars. Exactly, they're glowing because they're radiating. A whole shower of them coming by. They swirl around the capsule, go in front of the windows. They're all brilliantly lighted. They probably average 7 or 8 feet apart. That is critical. That means that's where they find their zone of comfort. Stay away from me, I'll stay away from you. That's a huge difference. The tiniest little particles have huge, huge, huge fields around them. When I show you some fields, you'll freak out. So he says, they swirl around, they probably average 7 or 8 feet, but I can see them all down below me also. So they're behind him because the sunlight is wrapping around and still hitting them down behind them. At a certain point, he'll lose contact with them. And he does lose contact with the station that he's broadcasting to, because he's in the middle of static. And static is nothing more than radiation. It's nothing more than radiation, static. So as these things are absorbing and giving off all that light, that's static. And that's why he's in there saying, can you hear me? Can you hear me? No, they can't hear him. They're never going to hear him until he gets out of that static. There's a layer, there's a zone, which I just showed you in the particle I showed you here, that is nothing more than static. This is just loaded with static, and that's the scrub. And that's the thing they don't understand. We're scrubbing. That's the heat zone out here. It's 27 or over 3,000 degrees in that zone where it scrubs the particles in space, which are particles. They're sunlight, and they're chunks. Stuff coming off of the sun is not just light. There's all kinds of things. It's called the solar wind. Okay, I'm going to make this extremely simple. Charged particles are being spewed out of the sun. And what is a charged particle? Charged particle is a particle, a chunk of matter that has an electric charge. It may be an ion, such as a molecule or atom, with a surplus or deficit of electrons relative to protons. It can also be an electron or a proton or another elementary particle, which are all believed to have the same charge. It can be any kind of a particle coming off the sun. It could be sand. We don't know what's coming off the sun. Now, it comes off of the upper atmosphere of the sun called the corona. Well, what's the corona? The corona is the outermost layer of the star's atmosphere. It consists of plasma. This outermost area out here is where it scrubs. The surface of the sun is 10,000 degrees. 10,000. Out here where it scrubs its atmosphere into the other atmosphere, which is what's called the quantum foam, it scrubs right here. Millions of degrees out here. 10,000 down here. How did it get to be millions out there? The only reason is because of the scrub, just exactly what I showed you. And this over here is what they're showing as the way the sun radiates. Well, see, this side is really glowy, this side is not. Why? Why is that? What's going on there? I could tell you why. It's because the sun is moving forward and spinning this way. That means this concussion zone is not only going forward, it's scrubbing harder because it's turning into it. This one's turning away from the particles, so it is much less intense. And I can show you this in a solar eclipse. Okay, watch this because it is very representative of what's going on in our solar system and in our galaxy. This is obviously the sun, and it's spinning through space going forward this way on the arm of the Milky Way. So whatever is in front of it, it has to go through. That's why it pushes and you get a spew of particles off basically one side because it's spinning at the same time. Now, all of the planets have to follow the sun. They're being pulled by the gravity of the sun to catch up with them, with the sun. So we're all being pulled behind the sun, being dragged by all of this debris, which is called the solar wind. And we have to scrub through it. Some days there's more debris because there's more debris in front. Some days there's less debris because we hit a spot where there wasn't a whole bunch of stuff in front. And when you look at the picture of the galaxy, you can see there's spaces where there's a lot of impact and spaces where there is not a lot of impact. So here we are on one of these arms, twisting around this way, spinning around the galaxy. Everybody's being pulled in, and at the same time it's crushing all these particles, creating this enormous glow in the center. It's just like taking a wrench and going, "Argh!" Because this is being pushed back as this flows through space. These arms are being pushed back. Now, you see there's areas that are blank and there's areas that are very dense. Well, if we're coming into a dense area, we're in trouble. The sun is going to just get really, really hot. If we come into an empty area, well, it's going to get cooler. Now, it won't happen instantaneously. These are enormous distances. I don't know how long it takes to get from here around to here, but I'm sure it's not in a lifetime. But I'm not positive of that. I really don't know. I do know, though, that wherever you see glow, it means there's a whole lot of particles there bashing into each other. That's the only way you get glow. Okay, it's as simple as it gets. We're scrubbing through space. We're spinning through space on the arm of the galaxy and twisting and everything trying to catch up to the sun. The sun is radiating out particles just like it showed before. One side is extremely brilliant and the other side is the trailing side. It's going this way, spinning this way. That makes its axis here. We can see that. and it makes its scrub zone on the outer edge here. That's why we have 3 little spots of radiation. Do you see those? The reason those are red is because they are serious impacts here, and they create a magnetic field around them to separate their zones. This is the trailing spot, so this is just coming off this way. The other one I showed you showed it very glowy this side and very not glowy that side. It was a representation. This is truth. This is the actual sun behind the moon. That way there we can see the radiation and we don't get blinded by the light. So don't forget now, this is John Glenn. He's coming around and he's seeing the light that's coming around here. Because as this light comes around, it starts to try to hug the Earth, and it will contour the Earth a little bit. So he's still literally in the dark, but he's seeing the light sweeping around and hitting the particles that are up in this upper atmosphere. And then they radiate out all this different colors. And he said they're luminous, they're glowing, they're spitting out colors, yes. And they can spit out all different colors because they're all different types of molecules. They're not just light, they are particles. Particles emit different colors depending upon what types of particles they are, and depending upon what type of impact is hitting them. If it's a positively charged ion, negatively charged ion, not charged at all of those are going to give different effects from these different little particles. But they're all going to add up to being static, and that is what John Glenn was in. That's why he was saying, can anybody hear me? I'm broadcasting in the blind. Well, yes, because you're in that zone right there, my friend, where you're stuck in a whole slew of little particles that are also radiating. Just like you're broadcasting, they are too. All right, here's what John Glenn was seeing. He was seeing these particles like this, whether they were red or green or blue or whatever color, bashing into the particles that are these dust particles around the Earth. And when they do, they radiate. This is nothing more than this bashing into other particles right here at the beginning of our Venturi. And then we actually separated the black and the white, muons from electron neutrinos, and they came back together over here. So I think this is fission and fusion. And here's the event happening. It appears to accelerate the light, and then they divide and come back together. And these are the 2 particles that divide and come back. And they've seen them divide at CERN and Fermilab. See, they've seen these particles. They really don't know where they came from because they smash particles head on and they just get debris. And they've sifted through and they found these and they realize this is the smallest bits that they can ever find. And I agree with that, probably is true, because they appear to be coming out of light. So, and they're all different colors, so it's not just the red. You see the green here? The green is the same particle, and I can show you, let me show you a better shot of the green. All right, here's a better blow up of this. Light spins. These are both spinning. They're spinning. Well, the green is not spinning as fast as the red. The green is spinning much faster than the red, and it actually barrel rolls the red. They never do that. They always go this way. They spin in this plane. This time it's spinning around like this. You see it? I never saw that before. That's because they're both going through the same Venturi at the same time, and the green says, get the hell out of the way. Its white hits the white of the red and spins it. Spin around like this. Now, the green is so powerful that it reconcusses out here. The red just barely has a taste left to it at all. And then you can see the red just pushes it and sort of spins off down here. This is obviously highly magnified. But we can see this stuff because we're using CMOS, and we're not interfering whatsoever with the process. It's only we're sensing extreme amounts of luminosity. Okay, mes amis. This is what John Glenn was seeing, was these particles crashing into the dust, illuminating, which when these particles crash into things, they illuminate. This is the illumination of crashing into our Venturi and actually accelerating the light and dividing the light into the muon and electron neutrino showers. These are the particles that Fermilab sees and CERN. These are only the smallest bits they could find. But they find them from collisions of just explosion of debris. And they know these are the smallest ones that exist. And beyond that, really, they don't have much of an idea. We can see that they are actually, these particles are actually part of light. When they divide into these little bits, they call these a muon neutrino and electron neutrino. They come from Dirac neutrinos, and they split. And that's exactly what we did. We split them right here. All right, this is from our light experiments. We created the muon from the muon neutrino, and that's a sterile muon. The electron neutrino turned into electron showers. There it is right there. This here together is what's called a Dirac neutrino, the two of them together, and then they split off into these muon electron shower. Now, this is what we did, accelerated the light, and every time a particle pushes any other particles, they glow. That's why I talk about the glow, and the same thing with John, and when something glows, it emits energy. There's the Dirac, see the black and the white, that's that. Now, this is what CERN does. And when they smash them, they see a lot of red, they see some really high-speed blues and greens. We do the same thing, only we used coherent light. So we have red only, blue only, and green only. But then what we did was we mixed the red with the green, and I'll show you the difference. See how they have so many reds they have? Red is everywhere because that's the outside of the atoms, and they give off the easiest push and shove. They just sort of bounce gently and give off red. But when you get deep down inside, then you get these real high-powered ones. See them little spinners? I don't know if you can see that or not. You see how they're showing them spinning off like crazy, all those white and blue and green, but the red is the background radiation basically, because that's the first impact zone that anything hits. And I'm sure Glenn was seeing almost all red. Now this is our division of the white from the black and then recombining here. That's pretty spectacular. And I've got a lot of this, but there's so much of it, it's very hard to do. But this is how the red particles exhibit. And these are neutrinos. Then they turn into photons, then they turn into a different type of neutrino, and then they explode into the separate particles, the muon electron showers. But they know this. They say neutrinos change flavors as they start to concuss. And this is exactly what it is building up concussion just before they explode. And the same thing happens with the red. It's not specifically, with the green. The green is the same thing. The green is much more powerful. This is a green particle right here. I got even a better shot of that, I think. Yeah, there it is. Look at that. And that only happens after it has its initial concussion of a different type of neutrino. And then as it stacks up, it forms this. And I can show you that actually happening, as a matter of fact. Oh, I can show you in the red, easy. These are the neutrinos. Then they go flat. You see them? They go flat for a while. And then they turn into the photons, and then they split. And exactly the same thing happens to the green. Here's the green doing the exact same thing. See, these are neutrinos. They're getting ready to turn into photons. Hold on one second. I showed you these particles can separate. When they go through the Venturi, they are separating. Exactly what CERN and Fermilab wanted to see. Muon neutrino, electron neutrino together, which is the Dirac, separating into a sterile muon and electron shower. There it is, sterile muon electron shower. And that's because of our Venturi. And that's because we're using light and not protons, which all they can see is debris. The stuff they see is literally just debris. This is what they see. What are you going to make of that? All you can see is, wow, look at that. That's about the best you could do with that. And they say, okay, the red has a certain energy. That's a flavor. The blue has a certain energy. The green has a certain energy. Yes. I agree with all of that. And here's the blue. It's a rocket ship. Look at it coming through. And it's slowing down, either speeding up or slowing down. I don't care how you figure it. But light isn't supposed to do either of those things. Well, it does it very easily. And this is in the atmosphere of Rodney's garage. This, and Rodney finally, I don't know what happened to him. I was bumped off of Facebook and I can't find him anymore. And I'm sure he was very, very disheartened by all, you know, he spent 7 or 8 years on this with me, and we've never had a single person pay any attention. Okay, so I basically agree with what they're saying here at Fermilab, is that there was a black particle and a white particle, or red or green or blue or whatever color, and that they have exactly what they say. They have an extended, fixed size, the black one. Never changes. It's one size fits all the different colors. But the other one is, the glowy side is either red or blue or green or probably almost any color. And it has no real mass to it, but it does have a very powerful field. And he also talks about the quantum foam, which is precisely what I'm talking about, is what we're scrubbing through. The quantum foam is all the light particles and ions and all those different things that they talked about, the dust and radiation, all that stuff coming from every luminous source, which is literally this stuff here, fills the universe, absolutely fills it. So all light is scrubbing through that as it comes towards us. The redshift, I highly question whether Hubble is correct about the redshift being able to tell us how far things are away from us. Because if the particles of light are coming through and we think there's nothing there, we're wrong. There is all kinds of stuff. And they have fields. And they are 7 or 8 feet apart. But they're still there. They don't interact enough to glow, except in the arms of the galaxy and so forth. But normally they're dark. It's just, oh, there's nothing there, you just go through there. No, it's there. It just doesn't have enough energy to display itself. That's why Don Lincoln says it blinks on and off continuously. He says empty space isn't empty. It continuously blinks on and off when these particles hit each other. Just exactly what John Glenn said. Only in the open vacuum of space, they almost never are seen. So we don't see them. Just like he said, when I come into the sunlight, they were gone. Well, we live in sunlight, so they're always gone. Now, I'll just leave you with this. These are fields in space. There's magnetic fields everywhere in space. And they are generated because there's spinning planets inside of the magnetic particles, and they create exactly like a motor does. It creates a magnetic field around it. I believe this is Venus. It has a double field. It's moving one way and spinning backwards. And I've never seen anything other than that. And everything is a dipole. You see, they're all dipoles. This is my theory, is the dipole flood theory. And everything is a dipole. And look at this. This is really, really out there. Now, this was Dylan. This is Rod's nephew. Now, Rod was in Australia. As far as I know, he still is. Dylan was in New Zealand, and I was working with them. Well, I didn't really work much with Dylan, only one time, actually. And Rod, I worked with for 7 or 8 years, maybe more. And finally, I got bumped off of Facebook. They deleted my account, so I lost everybody that I was doing research with, and I lost Rod. I can't find him. He's not. I have no connection to him anymore. And like I said, I'm sure he's probably about had it with the way we were treated by Fermilab and well, specifically Fermilab. I showed all this stuff to Don Lincoln, and he refuses to engage. He absolutely stay away from us. Don't ever come here again. What do you do after that?